Hey guys, Math 1. We are ready to start the last topic in Chapter 3. Now that we have talked about multiplying polynomials together, we are ready to start solving equations, one of which will involve multiplying polynomials together, but not today. Today we're going to start solving equations that have a variable in the exponent. And so let's do it. All right, so you can see on the board, we are solving equations that contain a variable in an exponent. And I actually start with a pretty easy example here. It'll be obvious what we're doing. What would the solution be for the problem at the right? All right, so what you should notice here is that since both bases are the same, right? The base is the thing under the exponent, and in this case, both bases are 2's. And if these two things are equal to each other, and their bases are equal to each other, well, then the exponents must also be equal. And so we can say that. We can say that the exponents are equal. 7 must equal 2x plus 1. If the two amounts are equal, right? If the two amounts are equal to each other and the bases are equal, then the exponents must be equal. And so we set up an equation that says that, and we solve for x, which would make x equal 3. All right. This is the basic of what we're doing today. And let me show you one more skill that will make this somewhat easy if you master this skill. So sometimes a number can easily be written as some other number to an exponent, all right? This is actually fairly easy, maybe, especially if you understand exponents pretty well. Maybe I'll do one and then you could pause the video and see if you could do the others. Maybe. So 25. I claim that 25 is a perfect square, and therefore it could be written as 5 to the second power. Right? So all I've done is take the number 25 and I've written it as some other number to an exponent. This is really easy to do if this number is a perfect square or cube, right? Then you can just write it as some number squared or some number cubed. But the second one's a little tougher. The 1/2. How am I going to write 1/2 as something to an exponent? All right, this is the trickiest kind. Ideally, I would like to take this fraction and I'd like to make it a whole number. And the way I can make it a whole number is by flipping it. Flipping it. And what type of exponents lets me flip it? That's right, a negative exponent. 1/2 would be the same as 2 to the negative first. So I actually did take the 1/2 and write it as a different number. A whole number is really nice, to an exponent. How about 16? I think you can do 16 two different ways. Do you know what they are? I know that 16 is a perfect square. So I could write it as 4 to the second power. But I also know that 16 is equal to 2 times 2 times 2 times 2. So I could write it as 2 to the 4th power. Either way works, right? and I have taken the 16 and written it as a number to an exponent, which is my goal here. My goal is to write each one of these as a different number to an exponent. How about 27? 27. That could be written as 3 to the 3rd power. How about the 8? Anybody know? The 8 could be written as 2 to the 3rd power, right? That is 2 times 2 times 2. Just like that is 3 times 3 times 3. And perhaps the trickiest one, 1/4. Okay, stay with me on this explanation for 1/4. I could write 1/4 as 1/2 squared. But I really don't want it to be a fraction. I'd rather it be a whole number. So I'd like to take that 1/2 and flip it. And if I flip that 1/2, I would get 2, right? But flipping it over makes the exponent change sign to negative. So this becomes 2 to the -2nd. All right, let's make a note of that. I think that is a good thing to remember. So a negative exponent flips the base. See how the exponent went negative and it flipped over the base, right? Okay, that is the trickiest kind. All right, if we have a handle on that skill, that we can take some number and we can write it as a whole number to an exponent, we are ready to see the whole thing now. So the way that we will solve equations that have a variable in the exponent is we will use this thing called the change the base method. This is one method you can use to solve an equation where there are variables in the exponent. And the way you want to do this is you want to change one or both of the bases so that they are the same on both sides. Now, because this is what we're doing, you will be able to do it, right? You will be able to find numbers that you can write both sides as to an exponent. This is how you change the base. You change the base by rewriting the base as a number to an exponent like we did in the examples above. This is what we just got done doing. It's the skill we just practiced. I do make a note here that this cannot always be done. So we would need other methods as well, but those are for a later course. In this class, we're going to typically have examples where you are able to change the base. All right. Once you change the base, then you'll see you're going to use exponent properties to simplify the expression. And the property you will use basically every time is the power to a power. That's when you have like 2 to the 2nd, to the 3rd, and that is actually 2 to the 6th, right? Because when you have a power to a power, you multiply them together. And now that the bases are the same, you set the exponents equal to each other, like we did in the very first example we did. All right, let's try a couple. Please stay with me to the last one. The last one is the most difficult. All right, so this first one is the easiest. The bases are already the same, right? I wrote that down. Bases are equal. And because the bases are equal, therefore, exponents are equal. And I can just go ahead and say 3 equals x plus 1. I can say the exponents are equal when the bases are equal, and I can go ahead and solve for x. And I would subtract 1 from both sides, right? And I'd get x equals 2. All right, that was the easiest. All right, this next one, the bases are also the same, but look, I need to simplify this. Simplify using, out of space, power to a power. So this would be 7 to the 3x, right? When you have an exponent raised to another exponent, they get multiplied together. And that would equal 7 to the 4x minus 3. And now I'm back to the same thing. Because the bases are equal, I can go ahead and set the exponents equal to each other. So 3x would equal 4x minus 3. And I can solve that. I can subtract 4x from both sides, giving me negative 1x equals negative 3. There's a negative there. And I can divide by negative 1. And I get x equals 3. All right, let's go to a couple more difficult ones. All right, letter C. So there's a couple different ways you could do letter C. But what I see immediately is that 16 could be changed into a 4. Now the 4 could be changed, but I don't need to. I could make the 4 a 2, but I don't need to because I just want to make both sides be the same. And I can make the 16 into a 4. All right, so I would make the 16 become 4 squared. So 16 becomes 4 squared, still to the x. And then simplify the power to a power. So then you'd simplify the exponents, and this would be 4 to the 2x. Right? Because you have a power to a power, you can multiply them together, right? And the other side can just come all the way down. And now I have the bases are the same. All right, you see how I changed the base from 16 to 4? And now I can set the exponents equal to each other. Exponents equal, and I can solve and get x equals 2. All right, we're making it slowly tougher and tougher. How about letter D? Letter D, fairly easy, right? What do you think we're going to do with that 9? Well, of course we are. The 9 is going to be rewritten as 3 squared. I don't know why I wrote that. 9 becomes 3 squared, still to the 2x. And then I simplify it. And I would simplify it, of course, by I have a power to a power, so I'm going to multiply them together. And that would be 3 to the 4x equals 3 to the 5th. I have made the bases the same, and so now I can set the exponents equal to each other. 5 would equal 4x, or if I divided both sides by 4, I get x equals 5/4. 2 more, guys, 2 more. Letter E. You probably could do this one on your own at this point, some of you for sure. The 8 can be simplified. The 8 can be changed to 2 to the 3rd power, still to the 70. So 8 becomes 2 to the third. And then I simplify. And I get 2 to the, let's see, that would be 210th. That would be a rather large number. Equals 2 to the x plus 5. And now that the bases are equal, I can set the exponents equal. 210 equals x plus 5, or x equals 205. All right, the last one. So in this one, both sides need simplified. I can't make the 9 into a 1/3 very easily, and I can't make the 1/3 into a 9 very easily, but I can make them both into 3s. The 9 can be rewritten as 3 squared, still to the 4th power. How do I change the 1/3 into a 3? That's right, I flip it. And how do I flip it? By making it a negative exponent. This would equal 3 to the negative first, right? Doing something to the negative first just flips it over. And that would still be to the x plus 3. All right, that's a big one. If you understand that, you are home free. You are now ready to simplify it. You can simplify the left side by multiplying the exponents together. And you can simplify the right side by multiplying the exponents together. And I'm going to do that in 2 steps just to point out what it is. -1 times x plus 3. So that would be 3 to the negative x minus 3. And I have made the bases the same. And now, finally, I can set the exponents equal to each other. 8 would equal negative x minus 3. Or if I add 3 to both sides, I get 11 equals negative x, or x equals negative 11. All right, you have learned to change the base to solve equations. Good luck on your homework.